Hello once again, my dear students, and welcome to another video for our class in object-oriented programming. In this video, we are going to look deeper and hopefully gain more understanding about the differences of classes and objects. Classes and objects are the most basic conceptual elements of object-oriented programming. And classes are program codes that serves as the blueprint or template from which objects are created. On the other hand, objects, they are the most basic unit of object-oriented programming. They represent real life as well as conceptual entities that your program may use. In a typical software, several objects work together and communicate with each other, performing their designed specific task. As an example, if we have defined a class called person, then the instances of the person are the objects. In this example, Danny, Grace, Emma, Jake, and Rio are all instances of the class person. And so, the definition of person are all being logically incarnated into these objects. Another example, if we have a class animal, we can create objects out of the blueprint of an animal and come up with objects such as horse, whale, bird, snake, and earthworm. So in a nutshell, classes are the blueprints or templates and objects are the products or instances. Through the process of instantiation, from the blueprint of a class, we can output what is known as object. So, for example, we have a class person and we put it into the process of instantiation, we can create an object which is a person named Eddie, or another person named Brian, or another person named Margie. For every class definition, we define into that class definition what are known as members. Objects have members. These include attributes, which hold the data about the object, and methods, which reflect the behavior of an object. Attributes are defined as global variables that are intended to hold data about a specific object, and methods are functions that contain executions of the task that a specific object can perform. As we talk about objects and their members, we can also identify data objects which are either class variables or instance variables. There are two types of these are the two types of the data members. The class variable, which belong to the general class, and the instance variable, which belong to a specific object. Class variables are defined with the static keyword. If there is no static keyword in a declaration of a data member, that means it is an instance variable. Here's an example, a simple definition of a class person. We have here three data members: the name, which is a string, the age, which is an int, and population is also an int. In this example, we see here that string name and int age do not have the static keyword, hence they are what is known as instance variables. These instance variables are the definition of the variable or data that will be copied to each and every object. So every time an object is instantiated out of a class, all the defined instance variables will also be copied, or this will create a copy of the instance variables that will be assigned to that specific object. On the other hand, we see here population has the static keyword, which means that population in this example is a class variable, which means that the population is not copied into each and every object. Instead, it is just assigned right there at the class and is accessible from within the class. However, it is also accessible from within the object. The difference is that when you are referring to a class variable, you are referring to one entity or one single value, no matter how many objects were created from that class. As an example, here is a class person which has the string name, the int age, and int population. Here in the UML class diagram, the underlined attribute pertains to a class variable, and the other two, name and age, which do not have underline, are instance variable. The dash in the beginning simply means they are private in terms of access modification. So when you instantiate a class person, you create an object of the type person. In this case, we have an object of a type person with a value for name Brian and a value for age 23. But it does not have its own value for population because population is a class variable and will remain within the class. If another object will be created through instantiation from the class person, you can have Sophie, which is the name, and 19, the age, and Reggie, and 34. All three of these objects share the same value for population because population is a class variable. However, they have different values in terms of name and age because name and age are instance variables. Instance variables are unique to each and every object, while the class variable is common to all the instances of the class. So that is why if, for example, in every instantiation of this class person, there is a code that is going to update the number or the value of population, when you are going to take the population of Brian, it will give 3, which is the same if you take the population of Sophie, it's also 3. And if you take the population from within the class, will also be 3. Just like data members, you can also have methods, which can be either a class method or an instance method. The Java programming language supports static methods. Static methods, which have the static modifier in their declarations, should be invoked with the class name without the need for creating an instance of the class. In this example, if we define a static method for person called getPopulation, then you can just invoke the method getPopulation from within the class or using the class name without even instantiating any object. Now let's take a closer look at these concepts in coding. So here we are once again in our Visual Studio Code editor. And we have here our initial code, which is simply a declaration of a new class called person. Inside of here, we're going to define the attributes of this class person. So we'll have private string name, private int age, and private static int population. So here, name and age are instance variables. Population is a class variable. Let us first have a method for accessors and mutators for name and age. So public void set name, string name, and this dot name is equal to name. Public void set int, set age, int age, and see this that age is equal to age. All right, and let's have some getters or accessors. Public string get name, and we'll return name. And from public int get age, we will return age. We can also add a constructor for this so that we can instantiate and initialize at the same time. So we'll have public person. We start with a blank initialization, and we'll say this dot name. Just put no name, and the age, let's just say 0. On the other hand, we can have an overloading of our constructor. We say public person, and inside of here we can put the name and the age. So string name int age, and here we can say this dot name equals name, and this dot age equals age. All of these are simply for initialization, accessor, and mutator. Now let's add a class method that is going to give the value or return the value of the population. So we're going to say public static int get population, and here we return the population. Also, when we create a person, that is during the instantiation, here we have two ways of creating a person, wherein first we create a person without parameters and without arguments, and we can also create a person with a name, argument, and age. So for each and every time we create a person, we're going to increment the value of our population. So we should say here population plus plus. Here all right, now let's try and create a class that is going to make use of this person class. Create a new file. Let's say person demo, and inside of here we're gonna put a main method. Okay, so here we're gonna create a person p1 is equal to a new person. Here we are using the instantiation without arguments, which will call the first constructor, wherein this p1 will have a name of no name and an age of 0. Let's create another one, person p2. This time we'll be instantiating it with arguments. Let's give it a name of Brian and an age of 45. And another one, person p1 or p3 is equal to new person, and let's give this a name Harry and the age of 23. All right, so since we have 3 instantiations, we have called this once and this twice, so the population plus plus statement has been called 3 times, and hopefully we have a value for our population of 3. So if we're going to ask, or let's add a method or person to give out the details of this particular person. So we can say public void show, and here we simply print out the details of this person. So we have name, and give it the name, and then we'll have age, give it the age, and we'll have total population, right there. So now we can just call show on any of our objects here, p1, let's show. Then let's also have a spacing here, just like that. Let's have p2.show and another spacing. Then p3.show and run this program like so. And here is our output. We have the first, this is p1, and it says there the name, no name, age of 0, total population 3, Brian 45, Harry 23, and all of them have total population of 3. Aside from that, we can also access the population from the class itself. For example, you'd say the total number of person is, and then you put there person dot get population. Remember that get population is a class method, so we can call that there from the person itself, from the class person itself. You notice that we're not using p1, p2, p3. These are the objects, person is the class, and we're accessing get population from the class itself. And from there we can run this program again, and you'll see we also have 3. Alright, so that is the difference between objects and classes. I hope that you have learned the lesson well, and try to practice on your own. Try to write some programming from some code on your own to increase your knowledge and skills in programming. That will be it for this session. Thank you so much for watching, and see you again in the next one.